So here we're going to look at a few more examples. I'm going to start, in this video, I'm going to look at the two series that are on the left, and then in the next video, I'll do that series that's on the right-hand side of the page. But once again, we're going to find the radius and the interval of convergence. The first one here, we have the series from n equals 1 to infinity, n to the nth times x to the nth. Since both are raised to the nth power, I'm going to use the root test to find that radius of convergence. So for the root test, we're going to look at the limit as n approaches infinity. And we're going to look at the nth root of the absolute value of n to the nth, x to the nth. The nth root and the nth power are going to cancel each other out, so we're going to be left with the limit as n approaches infinity of n, and that does not need an absolute value bar because it's always going to be a positive, times the absolute value of x. Now, as n approaches infinity, this is also going to go to infinity with one exception, and the one exception is if x equals 0. So again, this limit goes to infinity except where x equals 0. So here we're in one of those rare cases where the radius is 0. So the radius of convergence is 0. And then the series only converges at that point x equals 0. So we don't really have an interval of convergence here, just the series converges at that one point. So again, that's one of those more special cases. In the diagram on the first page, this would be the very last image. So this one is a lot shorter because there's no endpoints to test or anything like that. Now I want to look at the one just underneath this. So here we have got the series from n equals 1 to infinity, n factorial over 3 times 6 times 9, all the way up to 3n times x to the nth. Now, I'm going to rewrite this. We're going to make this a little bit simpler, but I'm going to rewrite this. 3 is 3 times 1, 6 is 3 times 2, 9 is 3 times 3, all the way up to 3 times n, which is literally just 3 times n. So if we think of the denominator that way, this can be rewritten as the sum from n equals 1 to infinity. So down here we would have 3 times 1, 3 times 2, 3 times 3, up to 3 times n. Well, 1 times 2 times 3, all the way up to n is written as n factorial, but each of those n values is multiplied by 3. So this can be rewritten as 3 to the nth times n factorial. And just to show you how that would work, let's say that the n value here is just 5. So this would be 3 times 6 times 9 times 12 times 15. So that's 3 times 1 times 3 times 2, 3 times 3, 3 times 4, and 3 times 5. Well, the 1, 2, 3, 4, 5 is 5 factorial, and then it's 1, 2, 3, 4, 5, 3, so it's 3 to the 5th times 5 factorial. So here we're just generalizing that. Conveniently there, the n factorials are going to cancel, and this is multiplied by x to the n. So we could rewrite this as just x over 3 to the nth power. And that's going to make it a lot easier to work with. So to find the radius of convergence, because we're raising it to the nth power, I'm going to use the root test. So we're going to look at the limit as n approaches infinity. And it's going to be the nth root of the absolute value of x over 3 to the nth power. So that's the limit as n approaches infinity of the absolute value of x over 3. Because the nth root, the nth power cancel out. We've said that a bunch of times before. Have to keep my x in absolute value bars, but of course the absolute value of 3 is just 3. Since there's no longer any n's involved here, we know that the limit is just going to be the absolute value of x over 3. For this to converge absolutely, that has to be less than 1. So in other words, the absolute value of x has to be less than 3. So there is our radius of convergence. So if we rewrite this, we know that on the open interval from -3 to +3, this series converges absolutely, but once again, we do need to check our endpoints. And at x equals -3, and again, I'm going to use this version of the series. We're looking at -1 to the nth power. And we talked about this in the very first example I did. This is going to diverge because of the nth term test. And then at x equals +3, we have +1 to the nth, which is just 1. And again, that's going to diverge because the nth term test. So our interval of convergence is again going to just be that open interval. And I can write it down here because I've got space. You might be wondering, is there ever a time when one of the endpoints works? Yes, there is. And we'll see that in the next example, which will be on the next video.